This is the future. Evolution.
So hello and greetings to everyone. This is Shlok and today I'm going to be saying you all about a technology that is affiliated with Web3. It is about blockchain. So let's start with the video. So what is blockchain? A blockchain is a distributed database that maintains a continuously growing list of ordered records called blocks. These blocks are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. A blockchain is a decentralized, distributed, and public digital ledger that is used to record transactions across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the consensus of the network. So, who did invent the blockchain? As explained by Wikipedia, blockchain was invented by Satoshi Nakamoto, the pseudonym of an unknown person or persons, in 2008 to service as the public transaction ledger of the cryptocurrency blockchain, which made it the first digital currency to solve the double spending problem without the need of a trusted authority or a central server. So now let's know about how is a blockchain used. While blockchain is still largely confined to use in recording and storing transactions for cryptocurrencies such as Bitcoin, proponents of blockchain technology are developing and testing other uses for blockchain, including these: blockchain for payment processing and money transfers. Transactions processed over a blockchain could not be settled within a matter of seconds and reduce or eliminate banking transfer fees. Blockchain for monitoring of supply chains using blockchain businesses and could pinpoint inefficiencies within their supply chains quickly, as well as locate items in real time and see how products perform for a quality control perspective as they travel from manufacturers to retailers. Blockchain for digital IDs. Microsoft is still experimenting with blockchain technology to help people control their digital identities, while also giving users control over who accesses their data. Blockchain for data sharing. Blockchain could act as an intermediary to securely store and move enterprise data among industries. Blockchain for copyright and royalties protection. Blockchain could be used to create a decentralized database that ensures artists maintain their music rights and provides transparent and real-time royalty distributors to musicians. Blockchain could also do the same for open source developers. Blockchain for Internet of Things network management. Blockchain could become a regulator of IoT networks to identify devices connected to a wireless network, monitor the activity of those devices, and determine how trustworthy those devices are and to automatically access their trustworthiness of new devices being added to the network, such as cars and smartphones. Blockchain for healthcare. Blockchain could also play an important role in healthcare. Healthcare players and providers are using blockchain to manage clinical trials data and electronic medical records while maintaining regulatory compliance. What are the business benefits of blockchain? The primary benefit of blockchain is as a database for recording transactions, but its benefits extend far beyond those of a traditional database. Most notably, it removes the possibility of tampering by a malicious actor as well as providing these business benefits. Time savings. Blockchain slashes transactions time from days to minutes. Transaction settlement is faster because it does not require verification by a central authority. Cost savings. Transactions needs less oversight. Participants can exchange items of value directly. Blockchain eliminates duplication of effort because participants have access to a shared ledger. Tighter security. Blockchain security features protect against tampering, fraud, and cybercrime. Blockchain owes its name to the way it stores transactions data in blocks linked together to form a chain. As the number of transactions grows, so does the blockchain. Blockchain record and confirm the time and sequence of transactions, which are then logged in into the blockchain with within a secret network governed by rules agreed to by the network participants. Each block contains a hash, a digital fingerprint, or a unique identifier, timestamp batches of recent valid transactions, and the hash of the previous block. The previous block hash links the blocks together and prevents any block from being altered or a block being inserted between two existing blocks. In theory, the method renders the blockchain tamper-proof. The four key points behind blockchain are: first, the shared ledger. A shared ledger is an append-only distributed system of records shared across a business network. With a shared ledger, transactions are recorded only once, eliminating the duplication of efforts that's typical of traditional business networks. Second, permissions. Permissions ensure that transactions are secure, authenticated, and verifiable. With the ability to constrain network participation, organizations can more easily comply with data protection regulations, such as those stipulated in the Health Insurance Portability and Accountability Act (HIPAA) and EU General Data Protection Regulation (GDPR). Third, the smart contracts. A smart contract is an agreement or a set of rules that govern a business transaction. It's stored on the blockchain and is executed automatically as part of a transaction. Fourth, consensus. Through consensus, all parties agree to the network's verified transaction. Blockchains have various consensus mechanisms, including proof of stake, multi-signature, and PBFT, which means practical Byzantine fault tolerance. Each blockchain network has various participants who play this role, among others. First, blockchain users. Participants, typically business users, with permission to join the blockchain network and conduct transactions with other network participants. Regulators. Blockchain users with special permissionless to overuse the transactions happening within the network. Third, blockchain network operators. Individuals who have special permissions and authority to define, create, manage, and monitor the blockchain network. Next, certificate authorities. Individuals who issue and manage the different types of certificates required to run a permission blockchain. Now, I've came to the end of the video. So please don't forget to subscribe the channel and like the video. Thank you.